Friends, the next topic we will continue with the attenuator. So what is attenuator? Attenuator is nothing but as we know, it's a 4-terminal network. Attenuator is a 4-terminal network which is inserted between the source and load. Andre source ಮತ್ತು load ಮಧ್ಯದಲ್ಲಿ ಅದನ್ನ insert ಮಾಡ್ತಾರ. Mainly it is going to introduce a specific amount of loss in the network. So a purely resistive network with no phase shift is involved here, and it is mainly used for the resistive impedance matching purpose and in place of a transformer. So andre transformer ಬದಲಾಗಿ ಇದನ್ನ mainly impedance matching purpose ಗೆ ಯೂಸ್ ಮಾಡ್ತಾರ, and it is attenuation is always expressed in decibel dB, and D is equal to 10 log PR by PS by PR, and D equal to 20 log of IS by IR, or equal to 20 log of n to the base 10. We have seen in the last video. So attenuation in dB equal to 8.686 into attenuation in ampere, ಅಥವಾ attenuation in ampere equal to 0.115 into attenuation in dB. Next topic, symmetrical T-type attenuator. So T-type ಅಂತಂದ್ರೆ R1 R2, okay, and this is these two are R1s and this is R2. Here R1 equal to n minus 1 divided by n plus 1 into R0, and R2 equal to n divided by n square minus 1 into R0. This is T attenuator, and pi attenuator is 2 R2s and 1 R1. R1 is n square minus 1 by 2n into R0. R2 equal to n plus 1 by n minus 1 into R0. Next topic, transmission line. So what is transmission line? Transmission line is nothing but it's a 2-wire cable, and the purpose is to carry the RF, that is radio frequency energy, for a desired distance. So it is going to carry the radio frequency signal RF energy to the destination, desired destination. What are the different types of transmission lines? The different types of transmission lines. Number one, power line. What is power line? They are used for the transmission of large quantity of power over a fixed frequency. So mainly used to carry the power till a long line for a fixed frequency. Communication. So these are nothing but example is your KB lines. Communication lines, here the transmission of small quantity of power over a band of frequency. Parallel wire transmission, which contains 2 wires separated by a ceramic athava plastic spaces, and air can be used as a dielectric. Example your telephone cables. Next we have a coaxial cable. So aden ಮಾಡ್ತೈತೆ, which is nothing but your dish TV cable, which consists copper conductor surrounded by an insulation irtati, and in turn it is surrounded by the tube shaped conductor of a solid copper athwa aluminum etc. Usually they use copper, and outer tube and central conductor share same axis. So ಎಲ್ಲವೂ ಒಂದೇ axis share ಮಾಡೋದಕ್ಕೆ ಅದಕ್ಕೆ coaxial cable ಅಂತ ಕರೀತಾರ. Example is your simple cable TV cable. Paired cable, so which contains large number of pairs of wires, and it consists of the 2 wires which are insulated by insulating material paired cable ಮಾಡಿರ್ತಾರೆ. And next we have important waveguide. So what is waveguide? Waveguide ಅಂದ್ರೆ ಏನು? It's a specially constructed hollow metallic pipe, specially constructed hollow ಇರ್ತೈತಿ, ಒಳಗೆ ಟೊಳ್ಳು ಇರ್ತೈತಿ, which is a metallic pipe used to carry EM, electromagnetic waves. Electromagnetic means which contains both electric as well as magnetic, and they are mutually perpendicular to one another, and these EM waves are used at the microwave frequency. This is very important. This is a primary line constant. RLGNC, RLR series, GNC are parallel. RLGCs are called primary line constant. R is a loop resistance, L is a inductance, G is a leakage conductance, and C is a shunt, C is a shunt capacitance. The transmission lines are low pass filter type of, okay, so it is similar to low pass type. So RLGC are nothing but they are distributed throughout the line. So these components are assumed to be distributed throughout the line. Okay, these are primary constant. Next, secondary line constants, which includes characteristic impedance Z0 and propagation constant P. So we are at the topic characteristic impedance ಮತ್ತು propagation constant. Next, characteristic impedance Z0 equal to under the root of Z by Y, or which is equal to Z is R plus J omega L, and Y is equal to G plus J omega C. Okay, and next, for a lossless line, so it is assumed to be a theoretical, so which is not true in the practical aspects. For lossless lines now we assume ಮಾಡ್ತೀವಿ our resistance is 0 and G is 0. Then Z0 equal to under the root of L by C. So this formula has to be remembered. Next, propagation constant P is equal to log to the base E I0 by II, incident by input by output. Ia is input current, I naught is a output current. This ratio is called propagation constant. Next, in case of lossless lines, andre when there are no losses, it is a ideal condition. Avagan P is imaginary and it is proportional to the frequency. P is equal to root of zy, z is r plus j omega l, y is g plus j omega c, it is equal to alpha plus j beta. So it's a complex form where alpha means attenuation constant measured in amperes per kilometer and beta is a phase constant, adanna radians per kilometer na measure ಮಾಡ್ತೇವೆ. Next concept, reflection. Reflection ಅಂದ್ರೆ incident light ವಾಪಸ್ ಬರೋದಕ್ಕೆ reflect ಆಗಿ ಬರೋದಕ್ಕೆ reflection ಅಂತೀವಿ. This occurs when the load impedance is not equal to the characteristic impedance. So when there is a mismatch in the impedance, load impedance and characteristic impedance ಒಳಗೆ mismatch ಇದ್ರೆ, and this the phenomenon of setting up of return wave ಅಂದ್ರೆ from the load to the source again ವಾಪಸ್ ಬರ್ತಾವ. Why? ಯಾಕೆ ವಾಪಸ್ ಬರ್ತಾವ? Due to the improper termination is called reflection. Reflection occurs because of the improper termination, and so the phenomenon of setting up of return wave from load to the source because of improper termination is called reflection. Point to be noted, and which is undesirable phenomenon. Idu agbardu. Next, reflection coefficient is given by K, VR by VI, where VI is a reflected voltage, VI is a incident voltage. Reflected voltage by incident voltage is called reflection coefficient. Standing waves. So as we know, the incident power which is applied to the line, it combines with the reflected power. So incident power as well as coming back, that is a reflected power, ಎರಡು combine ಆಗ್ತಾವ to produce a pattern of voltage and current variations along the line. If the load impedance it matches the line impedance, then there are no standing waves. Load impedance ಮತ್ತು line impedance match ಆದ್ರೆ standing wave ಬರಂಗಿಲ್ಲ, match ಆಗದ ಹೋದ್ರೆ standing waves ಬರ್ತೈತಿ. Next topic, standing wave ratio, very important from CET point of view. SWR, which is given by S equal to Vmax by Vmin, that is the ratio of maximum voltage to the minimum voltage, or maximum voltage is given by Vi plus Vr, minimum is Vi minus Vr. Incident plus reflected add up adra maximum, subtract adra minimum. So S is Z1 by Z. If ZL is greater than Z0, this is like this. Yes, Z1 by Z0, and S equal to Z0 by Z1 if Z0 is greater than ZL. Z1 by Z0, please make correction here, it is Z0 ಮಾಡ್ಕೊಳ್ರಿ. If ZL greater than Z0, otherwise Z0 greater than ZL ಇದ್ರೆ numerator ನ Z0 divided by ZL. If S equal to 1, then all the power is delivered to the load. This is ideal case. S equal to 1 ಇತ್ತಂದ್ರೆ ಇನ್ಸಿಡೆಂಟ್ ಪವರ್ ಅಷ್ಟು ಲೋಡ್ಗೆ ಡೆಲಿವರಿ ಆಗ್ತೈತಿ. And coefficient K is equal to Vmax minus Vmin divided by Vmax plus Vmin. Either the absolute value ತಗೊಂಡ್ರೆ ZL minus Z0 by ZL plus Z0. What is the relation between K and S? So reflection coefficient K ಮತ್ತು SWR ದ ರಿಲೇಶನ್ಶಿಪ್ ಏನಪ್ಪಾ ಅಂದ್ರೆ there was a derivation in your regular classes but here we are directly using the formula. So S is equal to 1 plus K by 1 minus K, ಅಂದ್ರೆ K ಗೊತ್ತಿದ್ರೆ S ಫೈಂಡ್ ಮಾಡ್ಬೋದು, or S ಗೊತ್ತಿತ್ತಂದ್ರೆ K ಫೈಂಡ್ ಮಾಡ್ಬೋದು. ಹೆಂಗೆ? K equal to S minus 1 by S plus 1. Next concept, open circuited and short circuited transmission lines. So at the short circuit termination ಅವಾಗ ಏನಾಗತ್ತೆ, current is maximum but voltage is 0 and impedance ಕೂಡ 0 ಇರ್ತೈತಿ. But open and termination ಒಳಗ current is 0, voltage maximum, therefore impedance is infinite ಅಥವಾ infinity impedance ಇರ್ತೈತಿ. Next, stub matching. What is stub? Stub matching is an open and short circuit section of a line. It's a open ಅಥವಾ and short circuit section of the transmission line, and this technique of inserting the stub between the load and source on the main transmission line is called stub matching. So we are inserting the stub between the load as well as the source in order to have a impedance matching. And for long frequency range, it can be done by using double stub. So sometimes we use a two stubs. And stub matching eliminates standing waves. So mainly stub matching is used to eliminate standing waves and the reflection ತೆಗೆದು ಹಾಕಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ. And next topic, antennas. So antenna is nothing but is a one which is capable of radiating electromagnetic waves. ಅಂದ್ರೆ ರೇಡಿಯೇಟರ್ ಮಾಡ್ಬೋದು, or it can receive the electromagnetic waves. either it is going to transmit or it is going to receive, and it is called EM, electromagnetic, because it is a combination of electric and magnetic fields. So some important definitions ಬರ್ತಾವೆ ನೋಡೋಣ. ಪೊಲರೈಸೇಷನ್ ಅಂದರೆ ಓರಿಯೆಂಟೇಷನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಅರ್ತ್. ಭೂಮಿ ಜೊತೆಗೆ ಏನು ಓರಿಯೆಂಟೇಷನ್ ಐತಿ, ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಯಾವ ಆ್ಯಂಗಲ್ನಾಗ ಓರಿಯೆಂಟೇಷನ್ ಐತಿ, ಅದಕ್ಕೆ ದ ಓರಿಯೆಂಟೇಷನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಅರ್ತ್ ಪೊಲರೈಸೇಷನ್ ಅಂತೀವಿ. ಇಫ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಈಸ್ ಪ್ಯಾರಲಲ್ ಟು ದ ಅರ್ತ್, ದೆನ್ electromagnetic is horizontally polarized ಅಂತೇವೆ. ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅರ್ತ್ ಪ್ಯಾರಲ್ ಇದ್ರೆ ಹಾರಿಜಾಂಟಲಿ ಪೊಲರೈಸ್. ಇಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಸ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು ದ ಅರ್ತ್, ಅವಾಗ ನಾವು ವರ್ಟಿಕಲಿ ಪೊಲರೈಸ್ ಅಂತ ಕರಿತೀವಿ. ನೆಕ್ಸ್ಟ್ ಐಸೋಟ್ರೋಪಿಕ್ ರೇಡಿಯೇಟರ್. ಸೊ ಐಸೋಟ್ರೋಪಿಕ್ ರೇಡಿಯೇಟರ್ ಇಸ್ an imaginary radiator assumed to be imaginary radiator which radiates uniformly in all the direction, and radiation pattern is spherical. It is also called as isotropic source ಅಥವಾ omnidirectional radiator ಅಥವಾ ಸಿಂಪಲ್ ಆಗಿ ಯುನಿಪೋಲ್. ಸೊ ಇಟ್ಸ್ an imaginary radiator. Actually practical we can't devise this type of radiator because it is going to radiate uniformly in all the direction. ಎಲ್ಲ ದಿಕ್ಕೊಳಗೆ ಆಲ್ 360 ಡಿಗ್ರಿ ಒಳಗೆ ಯೂನಿಫಾರ್ಮ್ ಆಗಿ ಅದು ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಮಾಡ್ತೈತಿ. ಸೊ ವಿಚ್ ಈಸ್ ಅ practically impossible thing to design such an antenna. Next, radiation pattern. So radiation pattern means it is a graph which shows the variation in actual field strength of the EM waves at all the points. Adre it's an equidistant from antenna. Antenna ದಿಂದ equidistant ಇರ್ತೈತಿ, and it is a graph which shows the field pattern ದೊಳಗೆ ಎಷ್ಟು ವೇರಿಯೇಷನ್ಸ್ ಐತಿ, ಅದಕ್ಕೆ ರೇಡಿಯೇಷನ್ ಪ್ಯಾಟರ್ನ್. And next, antenna gain is a measure of its directional properties, and it indicates the extent to which radiation is concentrated in a particular direction. ಯಾವ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಜಾಸ್ತಿ ಐತಿ, ಯಾವ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಕಡಿಮೆ ಐತಿ ಅನ್ನೋದನ್ನು ಡೀಟೇಲ್ಸ್ ಕೊಡ್ತೈತಿ. ಡೈರೆಕ್ಟಿವ್ ಗೇನ್ ಇಟ್ಸ್ ಅ ರೇಷಿಯೋ ಆಫ್ ರೇಡಿಯೇಷನ್ ಇಂಟೆನ್ಸಿಟಿ by in a particular direction by test antenna to that of a reflection antenna. So ಇದೊಂದು ರೇಷಿಯೋ. Directivity is a ratio of maximum radiation intensity in particular direction by test antenna to radiate intensity by the reflective antenna. Power gain is defined as a directivity of the antenna taking into antenna losses. So directivity of antenna plus losses ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಏನು ಸಿಗ್ತೈತೆ, that is power gain. Antenna efficiency is a ratio of radiation resistance to the sum of radiation resistance plus loss. Resistance divided by resistance plus loss, ಈ ರೇಷಿಯೋಗೆ antenna efficiency. And bandwidth is nothing but a range of frequencies over which its operation is satisfactory. ಯಾವ ರೇಂಜ್ ಒಳಗೆ satisfactory ಆಗಿ ಆಪರೇಟ್ ಆಗ್ತೈತಿ, that is called bandwidth. And finally, the beam width is the measure of directivity of an antenna, also known as beam angle ಅಂತ ಕರಿತೇವೆ. Beam width is the measure of directivity of antenna. ಯಾವ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಇರ್ತೈತಿ ಅದನ್ನು ನಾವು ಮೆಜರ್ ಮಾಡುವಂಥ ಥಿಂಗ್ಸ್ಗೆ ನಾವು beam width ಅಂತೇವೆ. ಸೊ beam width is nothing but it's a measure of directivity of an antenna. ಸೊ ದ ಡೈರೆಕ್ಟಿವಿಟಿಯನ್ನು ನಾವು ಮೆಜರ್ ಮಾಡೋದಕ್ಕೆ ನಾವು beam width ಅಂತ ಕರಿತೇವೆ. ಆ್ಯಂಡ್ ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ವಿಡಿಯೋ ವಿ ಶಾಲ್ ಕಂಟಿನ್ಯೂ ವಿತ್ ದ ಡಿಫ್ರೆಂಟ್ ಆಂಟೆನಾ ಟೈಪ್ಸ್.